In this video, we will discuss about goodness of fit test. So, what is goodness of fit test? This is a non-parametric chi-square test. We use this test if we have one categorical variable coming from a single population and want to infer whether someone's claim about the population distribution is true or false. Example: suppose a medical school claims that 60%, 30%, and 10% of their patients coming from low, middle, and high-income economic group, respectively. Question is, the claim is right or wrong? So, you take samples from the population and now you have observed frequencies for each class. Now, talk about the hypothesis. Null hypothesis: data came from a specified distribution. Against alternative, data has not come from a specified distribution. Think about the example. What will be the hypothesis here? You can see in the box. It is important to know the test statistic and its distribution. See the formula, where EI is the expected frequency in the ith level. OI is observed frequency in the ith level. Here, test statistic follow chi-square distribution with degrees of freedom, number of levels -1, say k-1. Decision rule. If test statistic is greater than critical value, or if p-value is less than alpha, we reject null hypothesis. Else we failed to reject the null. Now solve the problem that we were discussing. Let's you took a sample of size 200, and it shows low income group frequency equals 80. Middle income group frequency equals 70. High income group frequency equals 50. As per claim, your expected frequencies will be E1 equals 60% into 200 is equal to 120. E2 equals 30% into 200 is equal to 60. E3 equals 10% into 200 is equal to 20. Test statistic can be calculated easily. Here, test statistic follow chi-square distribution with df3-1 is equal to 2. At alpha, say, 0.05, find critical value from chi-square table. As test statistic is greater than critical value, we reject null hypothesis at 5% level alpha. Hence, our final conclusion, we can reject the claim at 5% level of significance.